Hi and welcome to this session. We talk about the any and all operators in subqueries. Let's create a new database and new tables that would help us explain it better. So I hope you still remember how to create a new database. Just going to do that now. If you can't remember, you can just follow me. I'm using the GUI method. So I'm going to call my database university, and I'm going to save it. So I have my database here. Now I want to create tables in my database, and I want to create two tables. I want to create a lecturer table and a student table. So I would create, I think I should use code. Well, let's use GUI. So I'm going to create a new table, create one with GUI and one with code. So pretty simple table. First one is called lecturer is fine. And check my columns. My table is going to have two fields or two columns, so name and then age for the lecturers. So for the first is name, and name is definitely characters as variable characters, so character varying. Name, maybe let's give it a length of 40, and I won't specify any key. I don't need key at this point. And add another field for age, and age is an integer, definitely. So integer, and save. So I have my first table lecturer. Let's create another table, but this time let's use code just to refresh our memory. So I'm going to open my query tool and remember the syntax. The syntax is create table, well, if not exists, I could put that if not exists. What do I call my table name? Student. Now I'm going to specify my table name, and afterwards just escape this, specify escape. So I have two fields as well in my table. It's just going to be name and age. So first field is name, and data type is going to be varchar, as variable character, and I'm going to specify the length. So I'll use 40 as well as the length. And then I don't think I have any other constraints. I'm not specifying primary key here. It's just for an example, so I'm not going to specify primary key or anything here. So for the next line, it's age, and my table name, my data type is integer, and I think that's all. And if I run this, so my table is successfully created. I'll just refresh this to see my table. So I have my lecturer and I have students. Let's just look through both tables to see if we have what we want. So select star from lecturer. Let's quickly run this. Okay, my fields are there, name and age. So let's check same for student as well. So for students, let's try it. And yeah, I still have my name and my age for students. So we're good. So let's insert some values into both tables. And we still remember how to insert values. So we say insert, insert into, let's start with lecturer. So lecturer, and then I'll specify my column. So lecturer name, name and age. So name first, then age. Then I specify my values. So I'll just take the values to the next line. Specify my values. So for the first name, my first name is, mind you, it's a variable character, so I'm putting it in semicolon. Sorry, inverted comma rather. Jane Smith. Jane Smith is my first lecturer, and age is 43. So for my second lecturer is Toby Joseph. Toby Joseph. My age is 52. For the third lecturer, name is Chuks Eze. Chuks Eze, whose age is 51. For the fourth lecturer, his name is Charles Harry. Charles Harry. His age is 35. And for the last lecturer, whose name is Adamu Ali. Sorry, I missed the inverted comma there. Adamu Ali, whose age is 40. And I close this off with my semicolon. So if I run this to insert my values, so my query ran successfully. So let's check what's in lecturer to see that all our values are there. So let's run this. And I have my lecturer. So let's insert our values for the student table as well. So we'll say insert into students. That's our table name. Name and age as well. Name and age. What values we are inserting? Our values are first name is Yemi Jack. That's my first student. Yemi Jack, who is 20 years old. My second student is Johnson Rivers, who is 21 years old. My third student is Sandra James, who is 19 years old. My fourth student is Emeka Paul, who is 37 years old. And my last student, who is quite old, is Chinedu Stephen. Who is 57 years old. So let's run this to insert into our students table. So we have our values inserted into our tables. Let's check the student table just to make sure. So now that we have imported our tables, suppose I ask a question, and my question is there any student older than all the lecturers? Is there any student older than all the lecturers? The query will be, I'll show us how to use the all function or the all operator to write this query. So what I want is all students that are older than all the lecturer, or any student who is older than every of the lecturers. So I'm going to write my query like this. And it's going to be select from students, student table, select star. So I want to select everything from my student table where age is greater than all. So this is where my all operator comes in now. Greater than all what? So all select age from lecturer. So like I said, the inner query or the subquery, which is what is in the brackets, is always run first. So first of all, it runs this select age from lecturer, and if I highlight that and run that, so I just run the subquery first. So you see the subquery, these are the ages in the lecturer table. So now we want to know if there's any student who is older than all the lecturers. So the oldest lecturer is 52. So is there any student who is older than 52? So this query now will check. So where the student age is greater than all of 52, all of the age in the lecturer table. And so if I run this now, you can see we have one particular student who is 57, Chinedu Stephen, and is older than all of the lecturers. So that's how the all operator is used. We use it to compare the main query with the subquery to see if a certain value in the main query is higher or lower than all of a set of values in the subquery. So what if my question changes to is there a student older than now any of the lecturers? Now you might ask, what's the difference between older than all of the lecturers or older than any of the lecturers? And we would see that in a bit. So my query doesn't really change apart from one part. So I'm just going to copy this. The only thing that changes is my all. I will just change this to any. So if I run this, let's run this and see our results. So you can see that we have two results in this case, and because our question is any student older than any of the lecturers? So Emeka Paul is 37, and why is Emeka Paul in our results? Is he older than, what lecturer is he older than? So let's see all the ages in the lecturer table. If I just quickly run this, you would see that there's a lecturer that is actually 35. So Emeka Paul, who is 37, is older than that particular lecturer. So for the any function, you don't have to be older than everybody in the subquery, or it doesn't have to be higher than everything in the subquery. It just has to be higher than at least one in the subquery, and then it shows up in our result. So that's how to use the any and the all operator in subqueries. So now we've discussed subqueries at large. We've talked about all the different operators we can use in subqueries. We've talked about the three scenarios where we can use subqueries: in the select statement, in the from statement, and in the where clause. And we've talked about different operators that we can use with subqueries. So in the next video, we are going to be talking about something really interesting. We are going to be talking about joins. We're going to be talking about joins, the different types of joins we have, and how to use them. So let's stay tuned and we'll see in the next video. And also there is a task at the end of subqueries that we are all to try our hands on. This is our second task in this course. So for that task, we are going to be using our pizza sales database. And we have two questions. First question is to find the sum of quantity of pizzas ordered per pizza ID for all pizza ID starting with the letter S. Sounds quite complicated, doesn't it, Bob? Something we can all figure out. So it's just to find the sum of the quantity of pizza ordered per pizza ID for all pizza IDs starting with the letter S. You are to order your results by the sum of quantity in descending order. So the first hint, I've dropped some hints. First hint is to use our order details table. And the second hint is that our result should have 21 rows. So you would know you're correct when you see that your result has 21 rows. Then for the second task is to write a query to show the list of pizza ID with prices higher than the average price of the pizza ID in the pizza table. And the hint is that your result should have 47 rows. So these are the two tasks for subquery. So we'll see in the next video where we're going to be discussing joins. Thank you.